Hello and welcome to my super high quality, really quick review of standard deviation. 2 of you asked me about this today and the test closes today. So I'm putting together the quickest video I could possibly put together to make sure we can go over this as quickly as possible. Let's get started. Okay, so standard deviation, when it is from a sample, it's S sub x. That's what we would see in our calculators from a population. It's lowercase sigma. What is it? Standard deviation is the average amount that each data point is different from the mean. So if we have a standard deviation of 1.5, on average, the data points are different from the mean by 1.5 points. It's different. So if you got a mean by averaging two things that are, by averaging dots that are really close together, this is a really stupid looking dot plot. This is a smaller standard deviation. On the other hand, and that's because the mean was right in the middle, right? And some were really close, some were really far away. If you got the mean by averaging data that was far apart, and the mean's in the middle, we add them together and divide by 2, or divide by how many there were, excuse me. This would be a, wow, I don't know what I wrote there. Larger standard deviation, because even though we had the same mean, all of the points are on average further from that mean than they were up here. How do I find it? Well, if I go to stat, edit, and put my data in L1, then I can go to stat, calc, one variable statistics, and standard deviation will be the S sub x number that comes up when you do that on your calculator. So you click stat, edit, and then put your data in L1, and then go to stat, calc, one variable statistics. And when you do one variable statistics on L1, the standard deviation will be S sub x. So from chapter 2 now, when we have a data set and we're told we got a normal curve with a mean of 300 and a standard deviation of 10, it's saying, okay, one, we know that 99.7% of the data is within 3 standard deviations. So we go 1, 2, 3, 1, 2, 3. That's a really bad curve, but you get the picture. And so one standard deviation away from the mean is 310, then another 10 for 320, another 10 for 330. Below one standard deviation, minus 10 is 290, minus 10 is 280, minus 10 is 270. And then we're able to say, okay, it was 68 in the middle, so we have 34% in each chunk. So 34% of the data is between 290 and 300. So between the mean and one standard deviation below it. And then we keep splitting up the rest of the data. We got 13.5 in each chunk. This is probably not part of what you wanted to review. 2.35 and 0.15, and the same on the other side. And we use the standard deviations to find that. When they give us the standard deviation, so if we do the same idea and they want the z-score for, I don't know, let's say somebody got a 285. So we would do z equals the, x minus the mean divided by the standard deviation. And so it would be 285 minus 300 divided by 10. You don't need to know anything about standard deviation to plug it in here. It looks like we would get negative 1.5. So, and that's the z-score, not the standard deviation. That was just, standard deviation was just what you plugged in here. So I don't know what you guys were having questions about. I think I've hit everything that we've talked about standard deviation so far. Please let me know if that's not enough, but that's what I'm going to do so I can upload this and message it to you. Hopefully it helps, and message me if there's still stuff that's unclear.